All right, so let's take a look at electricity. So electricity is defined as the movement of charge. And generally what we're talking about here is electrons. So let's take a look at a little situation here. On the left side of this picture in this clear liquid, this is a solution of silver nitrate, right? So kind of silver plus. And then on the other side here, we have a copper wire, so solid copper. We combine the two in solution, and then eventually we see that the solution turns blue and there's a white precipitate. So let's think about what this stuff is. This blue solution, you've kind of seen this in the quals, the labs. This is a copper. So this is copper 2 plus, or copper nitrate in this scenario. And this white solid that you're seeing, that's pure silver solid. So you can see they're kind of swapping places here. So let's take a look at the overall chemical reaction, and that it's 1 copper as a solid plus 2 silver pluses form a copper 2 plus and 2 solid silvers. So you can see there's a transfer of electrons. You can think about redox reactions, label the reductant, oxidant, whatever. But you can see in this process that as soon as you put this wire in there, the reaction starts going forward in the forward direction, right? We're forming products. And you see there's no outside intervention needed here. And so this is a spontaneous process, right? We have a negative delta G, which means that we can use this to do work. Now, if we just put the solutions right next to each other, it's going to be hard to extract work from this reaction. So let's take a look at how we're going to extract the work out of this reaction. So the first thing we're going to do is we're going to put them in 2 separate solutions. We'll have a solution on the left, solution on the right. And the solution on the left is going to be made out of 1 molar copper nitrate. And the solution on the right is going to be made out of 1 molar silver nitrate. And then in these 2 solutions, we're going to put electrodes. So in our copper solution, we're going to put a solid copper electrode. And then in our silver solution, we're going to put, in this case, a solid silver electrode. But this side of the reaction, later on, we'll see it can be any conductive material. It doesn't have to necessarily be silver or your element of interest. Cool. And then we're going to combine these 2 electrodes with a wire, and in between, we're going to put some kind of load on here. We're going to put an external circuit or whatever we want. And this is the part that's going to have work done on it, right? So this could be your TV, your laptop, blah, 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 whatever, whatever, whatever. And so think about the spontaneous processes here. They're the same as the ones up here, now just separated into cells. So the solid copper is going to get oxidized into copper 2 plus. But when that happens, it's going to release 2 electrons. Those electrons are free to travel up this wire through the external circuit, thus doing work, and then they end up back onto this silver. And when they get back onto this silver, what they can do is they can combine with the silver, so Ag plus an electron, to form solid silver. So you can see we've got the same reaction we had up here, except now we've separated it into 2 cells, and we've put a kind of external circuit in between, thus to extract work on it. The last thing you need here for this battery to work, or for this cell to work, is what's known as a salt bridge. So remember, you can't isolate charge. Everything has to be nice and balanced. So if we're having electrons move in one way, we have to allow the charge to be balanced. So this salt bridge is just salts in it. So like something like a nitrate would go over to this left side to help balance the loss of electrons. and then some other electrolyte like sodium plus would go towards the right side to balance this gain of negative charge from the electrons. And again, it's the same thing as the picture above. Think about what's happening on this side. We have solid copper turning into copper 2 plus 2 electrons. And then on this other side, we have a silver plus combining with an electron to form a silver solid. So here's the same picture I drew just from your book. Has all the same components, right? But it's all about separating the spontaneous reaction and putting some kind of work in the middle, or some kind of circuit that can do work in the middle. And so that's what's known as a voltaic or galvanic cell. And a voltaic or galvanic cell is an electrochemical cell that produces electricity that can then be used to do work from a spontaneous reaction. Right, so voltaic, galvanic, they produce electricity from spontaneous reactions, and then electrolytic cells are the opposite. So it's still an electrochemical cell, but instead of producing, it now consumes electricity. And instead of it being from a spontaneous reaction, it's to drive a non-spontaneous reaction. So still Gibbs free energy, still thermodynamics, just a different application of it.